Welcome to the Prevention in Cybersecurity topic. When you've completed this topic, you should understand the requirements of a security approach in order to be able to prevent successful attacks. To address the challenge brought on by increasingly effective use of technology by attackers, we cannot rely solely on legacy detection methods. At Palo Alto Networks, we believe that security must transform. Security products need to use big data analytics. Adversaries use automation. Protections need to be automated too. We need machines to defeat machines. Humans alone aren't capable of keeping up with the speed and volume of data associated with automated attacks. Both IT teams and attackers are adopting cloud, big data analytics, and automation to accelerate delivery. IT teams adopt to better deliver applications, but attackers adopt to better deliver attacks. We need to be able to deliver from the cloud in the same way IT teams are using these capabilities for their digital transformation. And here is what we apply analytics, automation, and cloud-delivered security to. We need end-to-end visibility in order to safeguard business usage of the network. And we also need the ability to block or prevent malicious behaviors. A security architecture must be designed to cover both visibility and enforcement of the network, endpoints, and cloud computing. There is further complexity in the mix of high-tech attackers and modern compute environments that must be addressed by a successful cybersecurity prevention architecture. Mobile devices require access to business-critical applications and software-as-a-service delivered applications. And cloud-hosted platforms and infrastructures also require security solutions which provide enforcement points throughout the current computing paradigm. As threats evolve faster and faster, customers need to be able to apply new security technology and products faster and faster. To address this, we must dramatically change the consumption model for cybersecurity technology. The consumption model is how customers purchase security. In the current consumption model, the customer has to wade through a number of security companies, all claiming to be the best in the cybersecurity business. They decide on a company and buy the security box or product. They pay for someone to manage the security box or product. Then they find and pay someone else who can understand the data coming off the security product. And they also need to find and pay someone in the operations center who can tie all the data gathered together from all the security tools in some coherent, usable report. Doing all this can take 6 months or longer. But with the ever-changing security environment and the speed at which attackers can modify their attacks, customers must repeat this process every 6 months. And 6 months may be too long to wait, as new exploits and attacks are happening every day. The model doesn't work. Consumers have to figure out how to keep up with our ever-changing security landscape. The consumption model itself needs to evolve. We talk about the new consumption model in the 3 evolutions topic. In addition to these challenges, users expect networks that are fast, open, and allow unlimited access. This is a great thought, but unrealistic. When we talk about providing network security, we must understand where data flows. In the past, network security was typically provided at one location. That's the ingress point of the network, where data traverses to and from the internet. Today, because data flows in many directions within an organization, we must establish security across multiple boundaries within our organizations. Network security is a necessity. Some things must be decrypted. Others cannot be decrypted. Some things must be blocked. Others cannot be blocked. A security architecture that can properly prevent successful attacks must have not only visibility and control, but highly granular visibility and control. Let's take a closer look at how an attack might be structured to help identify effective steps to better detect and prevent attacks. This shows an example of the cyber attack lifecycle for networks. Hackers have their own playbooks, and they have the flexibility to go off script as well. Attackers can be creative, and they will not always linearly follow this exact sequence. And stealing data is not always the attacker's goal. They can hold out the company for ransom, disrupt operations, or funnel money out. Once we've characterized the stages of an attack, defenses can be built for each stage to try to prevent it. The first stage of the attack is reconnaissance. Just like burglars and thieves, attackers carefully plan their attacks. They research, identify, and select targets, often using phishing tactics or extracting public information from an employee's LinkedIn profile or corporate websites. These criminals also scan for network vulnerabilities and services or applications that they can exploit. In the second stage, weaponize and deliver, the attackers determine which methods to use. They may choose to embed intruder code within seemingly innocuous files, like a PDF or Word document or email message. Once attackers gain access inside an organization, they can execute the malicious code. This takes us to the next stage in the attack, which we here call installation. The attacker will gain privileged operations and is then free to install additional payloads. Next, attackers established a command channel back through the internet so they can communicate and pass data back and forth between infected devices and their own system. Once they've established remote control, the attackers can perform a number of different malicious acts: data exfiltration, destruction of critical infrastructure, stealing of proprietary information. An inclusive security platform must block these different stages that attackers use to exploit a vulnerability and gain access to internal systems. For example, when an attacker hijacks an identity in the target environment, the security platform must be able to closely monitor and control communications to protect against unabated lateral data movement from that legitimate identity. Because of the problem of scale and the automation and innovation that is needed to address modern attacks, a prevention-oriented platform is required to have any chance of successfully protecting today's environments. Prevention can be thought of in terms of 4 key things: complete visibility throughout all parts of an environment, including network, cloud, endpoints, and remote users; granular control to reduce the surface area subject to attack; prevention of known threats; and prevention of unknown threats. Customers should buy into the fact that these are critical to consider, but it's not an all-or-nothing proposition. These capabilities lie along a security maturity curve. The ultimate goal is to implement all the capabilities, but it's typically accomplished in a series of steps. For example, a customer may have sufficient visibility to see the employees on their network, but not enough visibility over guests, contractors, and suppliers accessing their network. Customers can then focus on those as the next step. We'll see throughout the PSE courses how the Palo Alto Network Security Operating Platform provides these things.